Compound events can generally be handled in two ways, right? So if there's a compound event that you have to work out, right? So let's say there is the experiment. The experiment is tossing a coin and throwing a dice. Tossing a coin and throwing a dice. Right now, here, let's say you are asked to let's say look out for an event. Let's define an event, right? A, such that you need to get a heads on the toss of a coin, and you need to get a number greater than 4 on throw of a dice, right? So this is the event that you have to find the probability of. Now, one of the ways is just listing out all the possible outcomes in this compound experiment, right? And then finding out the favorable outcomes in your in the probability you're looking for, right? So the all possible outcomes of this event, right, the sample space will have, when you toss a coin, you get either a heads or you get a tails, right? So with heads, you can map heads with 1, heads 2, heads 3, heads 4, heads 5, and heads 6, right? And with tails, you can again map T1, T2, tails 3, tails 4, tails 5, and tails 6, right? So you can get any of these outcomes. So this is the sample space. Now, getting a heads and getting a number greater than 4, right, you will get heads 5 and heads 6 as the favorable outcomes in A, right? So A has the favorable outcomes in A are H5 and H6, right? When you count them, you get number of elements in A as 2, number of elements in the sample space as 12, right? So the probability of A becomes 2 divided by 12, which is equal to 1 by 6, right? So this is one of the ways in which you can solve this problem. The second method is using independence of events, right? So we'll use independent events method. Now, in using independent events, right, now the event A must now be subdivided into two events, let's say B and C, where B is getting a heads, right, and C is getting a number which is greater than 4 on the dice, right? So we have divided the event A, right, into two parts, getting an H on the throw of a dice, and event C, getting a number greater than 4 on the throw of a dice. Sorry, this is the toss of a coin, right? So event B, the favorable outcomes are H on a sample space of H and T, right? Because we split up this experiment, right? The experiment that was originally given to us, we have split it up into two sub experiments. The first experiment is tossing of a coin, right? Now the second experiment, the second sub experiment now is throwing of a dice, right? So the sample space here is 1, 2, 3, 4, 5, and 6, right? Now the event C has number greater than 4 becomes 5 and 6, right? So we notice that the probability of B, right, is 1 out of 2. Probability of C is 2 out of 6, right? Now let's look at B and C. Does getting an H depend on getting a 4 or a 3 or a 2 on throwing of a dice? It does not, right? So we can say that B and C, they are independent events, right? So B and C are independent events, right? Now if they are independent, then getting B and getting C, right? So probability of both B and C, that's what I'm looking for, because we have to get an H in the toss of a coin, and we have to get 5 or 6 on the throw of a dice, right? Probability of both B and C occurring is equal to probability of B intersection C, right, this is actually equal to the probability of A, right? So this is equal to the probability of B multiplied by probability of C, right? You would recall this relationship from our discussion on independent events, right? So probability of A then becomes probability of B, right, which is 1 by 2 multiplied by probability of C, which is 2 by 6, and we get the answer 1 by 6, which is exactly what we got from our treating of experiment A as a compound event and not splitting it up into two independent events, right? Now, you would find that this method of independent events is very, very useful once your experiment, it becomes more and more complicated, right? So far, we've just dealt with 12 outcomes, right? But what if we are going to deal with, let's say, throw of 2 dice, right? So when you throw 2 dice, the number of outcomes increases to 36. What if you are throwing 3 dice, right? The number of outcomes increases to 216, right? Therefore, this method is strongly preferred as the number of as the random experiments in the compound experiment, they become more and more complicated.